Okay, the integrand really doesn't present a problem for me to integrate that over x and y. What provides a problem, though, is the region. It's a unit circle centered at the origin. I want to look at a picture of it and kind of tell you why it looks difficult to deal with it. So no matter how I do these things, if I do it this way over here, um, it becomes more difficult for me, right? So you have something like this over here, where the top and the bottom are actually the same curve. You have to separate these things into plus or minus root functions. What's over here, if I do it this way, well, the left and right, really the same curves. You have to separate into two different functions, by the way, and you can do that just by using the square root. It just looks difficult, all right? So what I want to do is I want to avoid this, and I want to use the Jacobian for it, all right? So one thing I'd recommend is that looking at it, since you're dealing with a unit circle, certainly you could be looking at polar coordinates for that. And, certainly you should realize that in a polar form, I'll write this down for you. Whoops, sorry about that. That the radius centered at the origin, r squared, would equal x squared plus y squared. And you should realize that, in the Cartesian system, you could write down x equals r times the cosine of theta, and you could write down y is r sine theta. These are all things that you learned in your pre-calculus courses, by the way. Then, what do you do now? You do your, that's a legitimate substitution, by the way. You're going to put this Jacobian down. All right, so I got to do the partial of x with respect to r. Let me write that down for you. And that is going to be, let's see, so the partial of x with respect to r, well, I'm differentiating x with respect to r. It's going to be cosine theta. And then I got to do the partial of y with respect to theta. Well, that's going to be r cosine theta. So you do the product of those two. What are you going to get? R cosine squared theta. All right? So I want to point out we just did this thing here, and we got what they said they're going to get, which is r cosine squared. Well, let's do the next one, and that's going to be the partial of y with respect to r. And that's going to be sine theta. And then we're going to do the partial of x with respect to theta. And what's that going to be? Minus r sine theta. Well, if you multiply together, you get minus r sine squared theta. And what are we doing with that? We're going to subtract it away. And what does that look like? It looks like this now, r sine squared theta. Right, what do you do there? It's Pythagorean in nature, so you factor an r out, and what are you left off with? R, and then you left off a cosine squared plus sine squared theta, which is just 1. The absolute value of that is just r. All right, so we get something pretty simple over here. All right, so let me get my eraser out. I'm pretty satisfied that we're able to do that. And again, the big problem is always those limits. I mean, that's even true when we just did the regions, and the regions were nice. It's the limit. So what do we get over here? Let's write this down. We're going to write the integration down. We know the region. X squared plus y squared is r squared. Let me remind you that x squared plus y squared is r squared. And then the dA was r, dr, d theta. All right? Now here comes the problem here. I'm looking at my unit circle. And it looks like this over here. And I hope you realize you know the radius is 1. So I'm going to say we're starting here, and we're moving out to the edge of it. So the r is going to go from 0 to 1. And the theta, if you think about it, we're going like this to cover that whole thing. It's going to be from 0 to 2 pi. All right, let me erase my picture, and let's get busy with the integration. R squared times R, I want to get my eraser out and get rid of that, is just R cubed. I'll write that down for you. Let's do it. So what are you doing over here? I want to do this first. Can I do it? Yeah, I can do it. What do you get? R4 over 4, 0 to 1, and that would just give you 1/4. So let me write this down again. What do you get? Equals 0 to 2 pi, 1/4 d theta. Can I integrate that? Yeah, it looks pretty simple. What do you get? 1/4 of a theta from 0 to 2 pi. What do you get there? 1/4. 2 pi minus 0 is just simply 2 pi. So you get pi. I'm sorry, that's 4. Sorry about that. What do you get there? 2 pi over 4, which can be pi over 2. Doing it again. And we are done. Thank you.